AI. Thinking Machines, Rising Robots. Daniela Roos will be our first speaker, then Moshe Vardi, and then Manuela Veloso.
Hello again. So I'm just going very fast since you had me this morning for quite a long time. So as a roboticist, I really would like to encourage all of us to think of machines as tools, incredibly powerful tools, but nevertheless just tools. And I would like to make the observation that people just assume that robots will put people out of jobs. And I would like to pose the question of what if robots could actually make many more jobs and better jobs. And in particular, I believe that by combining robots with AI, we can give factory workers extraordinarily fine granularity for controlling what they do in factories. And we might be able to move manufacturing and production from today's model, where we have fixed products that get designed with fixed templates and get manufactured offshore, to a situation where we have templated products, where the products can be customized and designed in your own home and fabricated locally. That's one point. My second point about robots is that we already see the benefit of bringing robots to people. So we are all betting on a future with autonomous cars. I believe that autonomous cars will be most valuable in low complexity environments, on private ways. The technology is ready to be deployed in environments like that. And if we could put autonomous robots in retirement communities, for example, our parents and grandparents will have much higher quality of life in their retirement. Now, the same technology for autonomous driving can also be mapped onto wearables, and with that, we can enable blind people and people who are visually impaired to experience the world in richer ways and possibly even enter the workforce at different levels than they're able to do now. And but of course, there are a lot of challenges, and so the technology is actually not ready for prime time. In particular, I would like us all to remember that crunching large data is not knowledge. Making complex computations is not autonomy. Correctness is exponentially harder as we get closer and closer to the 99.9% limit we want. Also, data crunching is easier than perception, which is easier than perception plus action, which makes robots. And finally, tasks with physical contact are much harder than tasks like driving or like flying or swimming, where you are not in contact with the world. So with this, I would like to leave you with a quote from 1962 that still rings true to me. Thank you.
Do you flip? What?
Just forward.
Okay.
There you go.
So we heard an amazing lunch talk about AI in China, but we had little discussion of what are going to be the societal consequences of such massive deployment of technology. And I must confess that for the first 30 years of my research career, that was my modus operandi. I'll develop technology, other people should worry about the consequences. But about 5 years ago, I decided maybe I have a moral responsibility too to what the consequences are. And so we hear a lot now, AI, there is almost no day we don't hear something about in the newspapers, in the media, about AI threats, AI issues. So let me try to put kind of a taxonomy on it. The one you hear, unfortunately, the most about is singularity and superintelligence. And of course, I can spend a lot of time just talking about this, but I'd rather not, other than put an epitaph that I just read recently describing superintelligence as the idea that it smarts people. And I'll say no more about that. But there are some very, very serious issues that I think we need to face. And probably the biggest one is, what kind of decisions are we willing to delegate to machines? So it comes up, for example, the issue of lethal autonomous weapon systems. Okay? Should we have, as they call, killer robots? That's the other phrase you hear. Should we autonomize weapon system? People talk about robot judges. Maybe human judges are flawed. Should we delegate judging to machines? These are big decisions that have to be made based on not just issue of effectiveness, but also on philosophical issues. At the same time, it will be very clear that there will be wide deployment of AI technology. And we've already heard some references to the fact that we need to think about transparency and explainability, accountability, verifiability. Jennifer Chase talked about fairness, which I think is an equally important issue. And there's another important issue people forget. These machines do not operate in vacuum. They operate in a human society. And we have much less control over the human part than we have over the machine part. So you can think of what happened in the past 10 years with massive deployment of AI. Google and Facebook deployed AI on a massive scale. And I would say the first round of algorithms versus humans won. And we have seen the recent later how basically people who wanted to figure out how to manipulate AI systems. And the final point is about the impact on the labor market, which is the major topic of this meeting. So I'm going to put 2 slides about just numbers. This is not about the future is here. This is labor force participation. This is how many people participate in labor force. This refers to men who are affected more by women. The picture is more complicated because 1960s, first of all, they enter the workforce. And you can see here that men have been dropping out of the workforce now for 50 years. So this is not some AI in the future. This is about technology today. And it gets even scarier when you go and you look at it by education. And you see that people with bachelor degree also have been affected, but the group has been most affected are people with high school degree or less. And we're talking about 60, 70% of the population. So if you look at it, you realize it means that right now, 1 in 5 men with high school degree or less is not working. Not in the workforce. And if this is not a crisis, I don't know what the crisis is. Thank you very much.
How does this work? Is here? Okay. So I'm just going to tell a little bit about something that not many people talk about, which is mobile robots that move around. So this concept of having mobiles that move around, and I think that none of us has seen this morning any robot moving around in our spaces. I walked into MIT, could not see any robot. I came down here, no robots anywhere. Many cell phones for sure, many laptops, but no robot anywhere. And we have been trying to understand how to put together this sensing, this thinking, and this actuation for an eternity. I've been at Carnegie Mellon University for 30 years, and I still work on this problem of putting this all together. Usually in my talks, when I talk, I assign as a homework, if you do not have, buy a Roomba. I don't have an interest on Roomba, but there is like Rod Brooks there. But you have to say, I always say, buy a Roomba. If you don't have, you pay the $900, you buy the best Roomba, you can control it from your cell phone, it cleans anytime you're home, but it moves. It's remarkable to have something that moves by itself. Your refrigerators don't move by themselves, your cell phones doesn't move by themselves, your cars don't move by themselves yet, but the Roombas do. And so that's very important to get that experience for your children, for yourself, to understand that AI can be in a mobile platform. So we have been trying to do this at Carnegie Mellon yesterday. These Cobalt Robots up there were navigating in the building, distributing candy as a Halloween treat. And by themselves, I tell you, I was in my office all day, and these things were roaming around, stopping at the right place, telling people, would you like some candy? Yeah, thank you, happy Halloween, bye-bye. And it was a robot. It was not a person. It was a robot with its perception, with its decision-making, where should I go, how long should I wait that people opens the door, and its action. It actually was moving down the corridors, and it came back when it needed to be charged. Fantastic. So we have to get to the AI level, to AI and robotics at that level. So this is what I pursue, and I want to just say 2 things. It seems that we are always thinking that robots will be these fantastic creatures that can do it all. We have to acknowledge that robots, like humans, you and me, have limitations and will always have limitations. They will not be able to process all the image. They might not be able to open all the doors of the buildings. They might not be able to understand everything you say. That's perfectly fine, but I just think that you need to accept that they can ask for help, they can learn, and they can be instructed. So it's another paradigm, is this thing that these creatures will be around and we'll be able to interact with that at that level. Finally, in this kind of like world in which AI will not just be on our cell phone, on our cameras, but will be also on the mobile creatures around us, we have a challenge of having these humans interact with these AI systems in a new way. These AI systems, when they stop in front of my office, I want to know, where did you come from? I mean, it arrives in front of my office. What are you going to do next? Why are you late? And so we need, from an AI point of view, from a research point of view, to have this autonomy, which we cannot follow, be described to us, be verbalized, be questioned. How often did you do this? How many people were in the kitchen? All sorts of questions that we might have about our physical space. And this is what we have introduced, different levels of explanation to enable these AI and robots to verbalize their experience so that these humans and these AI robots can interact better.
This is great. Let's see how much time they're giving us. We're watching the number go up. Good, that's great. So was it, let me now help remember the time. Was it 2015 when the DARPA Autonomous Robot Grand Challenge, Rescue Robot Grand, has it been 2 years now, 2.5 years? Mm-hmm. So what struck me about that Grand Challenge was that all of the robots were teleoperated. That there was, you know, a year before that, Andy Rubin, who was the Google roboticist at that point, told me he planned to have his Japanese subsidiary at the point where he would be able to push a button and it would complete all of the tasks. And of course, that Japanese subsidiary didn't enter. They became a supplier to the other component people. But so if that was ground truth 2 years ago, that all of the entrants were teleoperated, have we made meaningful progress since then? Well, in terms of autonomous machines?
I believe we have made tremendous progress. I will, before going to the DARPA challenge, I would like to talk about driving because we have much more history for driving. The first autonomous car was in Germany, I believe, in '87. And then the No Hands Across America project was in 1995. And then we had the DARPA challenge projects in 2004 and 2007. It really does take a very long time for the robotic technology to mature to a point where we can get it out of the lab. So I would say that since 2015, we have tremendous progress. We made tremendous progress in a number of ways. So we have seen a lot of advances on soft robotics. And with soft robotics, manipulation and interaction with the world gets easier because the soft bodies are much more tolerant of uncertainty. And so we have also seen great progress in perception, and we have seen progress on data sets. And generally, with all the investments in the area, we have seen significant results in terms of enhancing the capabilities of the robots, but these robots are still not ready to get out of the lab and be autonomous where you push the button and they do anything you want.
So yeah, I think that I completely agree. Though there are like demonstrations of these kind of capabilities that have been more deployed probably than others. In some sense, these Cobalt robots at Carnegie Mellon that go around like for kilometers and kilometers, they are not very smart in terms of being alerted. If someone is lying on the floor, this thing does not call 911. It just doesn't, which is very disturbing, and that's the PhD thesis of several of my students now. They navigate well. They are capable of reliably avoiding obstacles. They know their routes, but they are completely oblivious to whatever happens around them. So in that sense, you know, we have to dramatically make them more robust, more intelligent. But when you see Jan LeCun's technologies about all this deep learning, all scene understanding, my hopes are really high that we can put much more into these mobile creatures that move around avoiding obstacles, to now understand much more of their scenes. And now from a mathematical point of view, we'll figure out how to have multiple models, how to switch between them, and how to actually understand the complexity, not just of the physical space, but the physical space combined with this kind of like awareness that makes probably all of us more intelligent than just navigators.
Moshe, did you have a?
But we have to remember, if we go back to the focus, which is the future of work, we don't need complete autonomy to have major impact on work. So take, for example, autonomous vehicle. Probably the first deployment will be with long-distance tracking, okay? Because it's much more easier to do than to deal with cars in the middle of Manhattan, for example. And suppose you don't have full autonomy. Suppose it is teleoperated, but one operator can oversee 50 trucks.
Do you really think that's true? I have
Not
to challenge
yet.
you on that.
Not yet. But the point is, we don't need full autonomy.
But there's this thing called the handoff problem.
but-
I can imagine the difficulty of handing off one-to-one autonomous machine. What happens if you hand off to 50 autonomous machines?
Well, all you need
How
to
could
do
that
very
happen?
often is to slow down and move it to the side, right? I mean, you don't need to deal with all the situations. These are, if you think about it, you may have special lanes. But the point is, we can argue exactly when it's going to happen, but you don't need full autonomy to have major impact on the labor force.
Yeah.
I'm so happy to disagree with you, Moshe.
Good. We are hoping we had some disagreements.
So I think it's what you're describing is a really hard problem, and the way I think about robots on roads is in terms of the speed at which they're moving, the complexity of the environment through which they're moving, and the complexity of the interactions. So we can do what you are proposing, perhaps with very slow-moving vehicles, moving maybe on factory floors or moving in areas where we really do not have to react very fast. But I really do not see the trucks on the highways anytime soon. In fact, I made a bet last night that they will not be on roads before 2020. Until after
2020.
2020
is now.
No, 2022. Sorry. So
2020.
5 years of work. So past 5 years of work, we will see where we are. But 5 years is a really long time.
No, 5 years is a very short time. I disagree with you.
Manuela.
So I think that these, many people are focused on the autonomous robots outside, the cars. I like to think about autonomous robots indoors, like mixed up with humans, in shopping malls, in airports, in hospitals, in schools, helping people move around, in nursing homes, the whole kind of like Twitter of robotics. Robots that are just around. They don't solve big problems. They are just around. And eventually, it's not a question of whether we actually need automation. It's just it will exist, that type of automation, whether we need it or not. It's part of our human nature to have invented it. Did we need electricity when we had candles? Probably not. But it's just part of what we are. We invent, we create, we enjoy, we make progress. That's it.
So
what is this thing about needing autonomy, Moshe?
So I have a friend whose job is to head robotics at Google X right now. And his challenge, and I'd like to ask you if you were going to give him instruction, what is the next robot in the home after the Roomba? If you were going to say, what's the next product? It seems like it's not clear to me. It's a pretty hard bar to the next, if it has to move around, if it has to be mobile.
Folding laundry.
Oh, I would love that robot. I'm not sure that we're going to have it anytime soon. It's my least favorite chore, so I would love to have a robot that will fold the laundry for me.
Taking the dishes out of the dishwasher.
Like the laundry is good, but also just a robot that's in the house. I'm cooking dinner for some guests. Is the one that welcomes the guests at the door, serves people while I say, how many times are we all stuck there finishing something for dinner and the guests are coming and we are all like, oh, yes.
Well, so the appetizer serving robot.
I will switch with Manuela. I will let the robot cook and I will greet the guests.
Can I, so I would like to switch the example away from the home. And I would like to talk about a robot that is possible for us to have today. Yeah. And this is, in fact, an indoor robot, and it's a robot that all the physical therapists in our area would like to have. So today, when physical therapists work with a hospital patient, they have to walk to the hospital bed. They have to get the patient in a wheelchair, push the patient often 200-300 yards to the gym, they exercise in the gym, and at the end of the session, they have to do the whole thing all over again. These physical therapists would love to not have to do the empty part of their job, which is to walk back and forth to the hospital rooms. Instead, they would love it if patients could just show up in autonomous wheelchairs. And we have the technology for autonomous wheelchairs. We can completely enable that. So this is an example of an indoor application that does not put the physical therapist out of a job, but quite on the contrary, gives the physical therapist and the patient much more quality time together.
Yeah.
I completely agree, and you can think also in nursing homes. I once talked with a person in a nursing home who was afraid of leaving her room because to go to the dining room, which she perfectly could walk, but she thought that she would forget her way back to her room. And there is a lot of people that have these abilities that eventually, if a robot would just guide this person and guarantee to bring this person back. So we could invent all sorts of, like, in particular, navigation, not to just talk about the manipulation tasks, that could be of use to populations that have limitations or to make other jobs much easier.
And do you think that will be done with a robot, or could it be done with a disembodied AI like a Siri, offering guidance without something?
It could be also Siri, but it's actually a very good point. Some things you may want embodied because, as Cinti Brazil has shown and many other people, sometimes the embodiment makes the interaction be more natural, more fruitful. But again, some things might just be able to be on a cell phone or also on the real robot.
Yeah.
And it's just a question of testing.
Moshe, okay.
But I want to disagree, if you allow me, with Daniela again, to say, and with some other speakers to say, oh, this will enable the physical therapist to have more quality time. This will enable the teacher to have more quality time. This happens not in my world. In my world, everybody's under tremendous pressure of productivity. How many patients do you see per hour? How many students are you handling? And if you have automated, let's say, grading exams, I'm not convinced that what will happen is it will give the teacher more time for personalized interaction, or it will to say, okay, now you can handle more students because we have offloaded the grading from you. Or the physical therapist will say, okay, now you can see more patients per hour because you don't have to walk to the hospital.
So automation leads to speed up then, is what you think?
Automation is an enabler. What we do with it is our choice. Okay?
I agree with that.
Automation is an enabler. We can decide that we will have enable teacher to have more quality time with students, or physical therapist more quality time with their patients, or we can decide that we need fewer teachers and fewer physical therapists. That's our choice. That's not technology. That's on us.
Well, it's totally on us. And if I would say, this actually raises very interesting questions about what are the business models that we will introduce to allocate prosperity to people. And I think that we have an opportunity to rethink how we allocate the benefits that come from technology. I would say that in January, we did a study, we did a transportation study where we looked at the impact of ride sharing for rides in New York, and we showed that the 14,000 taxi drivers who are now supporting 400,000 rides every day could be mapped onto 3,000 drivers, provided that people agree to share and they don't mind if they get delayed by 2 or 3 minutes to get to the destination. We can actually put bounds on what the delays are. And so the first reaction to this work was, wow, we put 11,000 people out of a job. Well, an alternative interpretation is to say, let's change the business model. There is the same demand in the system, and that means that the taxi drivers can make the same wages, working fewer hours. The business owners can make the same profits. But now the benefit is that the taxi drivers have shorter shifts, and the community at large benefits because there are fewer cars, there's less pollution, so generally the whole community, the whole city benefits. So I like to share this example because it really points to new ways of thinking about how we allocate prosperity.
It will enable the taxi driver to have more quality time with their passengers.
So, we always think about this problem of labor, And this is the topic of our discussions today. And I keep thinking that eventually the fact that we invent new technology, the fact that we create new computers, new robots, will open jobs and creativity to many people. I mean, imagine people designing now the new robot, understanding exactly the functionality, creating more apps. It's like a kind of endless space. Think about the day the printing book came out, all the way to fax machines, to all sorts of like menus on, I mean, look how many things came from just books, if you think about the 1400s. I mean, who knows how far we'll go, but people, I have a lot of belief in human mind to be extremely creative and to, around this technology, create an enormous amount of jobs, probably, that we cannot even foresee today. My grandmother, my grandfather never thought that I would be swiping a cell phone. I mean, what is that thing of doing like that with your finger on some cell phone? It was absolutely inconceivable for a couple of generations before that this was going to be something that people would be doing. So think about letting people be creative, letting people be, letting their talents have a value. Maybe even in the new job economy, it's going to be more about your talents. Yeah. What can you do rather than what you are forced to do? And I just want to say one final thing about this. I wonder how many of these people that eventually robots and AI technology will displace from their jobs love their jobs. And every morning they think, oh, I'm looking forward to going and cleaning the bathroom in all these hotel rooms. Who is like looking for that? Who? But maybe it's the only thing they can do, but why can't we invent self-cleaning bathrooms? I mean, we can. And so what I'm trying to say is like this. The quality of life of people eventually will be very much tuned to their capabilities, to their interests. And maybe from an economical point of view, that will be worth to if you do what you like very well.
You began, Manuela, by asking where the robots were. And yes. Isn't it the case, if you look at the sense of the robots, most of the robots today in America are in the automobile industry?
Yes.
Which took me to Daniela's point about flexible automation. And once upon a time when Tesla was bringing up the X factory in Fremont, I got the tour, and it was a beautiful line. But it was a very Detroit-like line. It was a line that only made S's, and they said, oh, maybe in the future we'll make X's, and it looks like they're having trouble moving over to making 3s. So, but you raised the possibility of this much more flexible manufacturing world, and it looks like it may not come from the automobile industry. Will it come from somewhere else?
Well, it has to come from the science community, right? I mean, we have to invent the algorithms and the systems that allow us to think about modular design, that allows us to automate the design and the fabrication, and that allow us to kind of mix and match. And there are so many technologies that are being developed. There's so many advances that are directly impacting this kind of vision. 3D printing and all sorts of rapid fabrication technologies, but also our ability to automate design and our ability to go from concept, from the idea of what this object you're trying to build might do, to an actual design and to an actual instantiation of that design. Now, I'm not claiming that we have fully solved that problem, but we already have proof of concept systems that I imagine in some number of years will become much more robust and ready to be deployed in applications.
And in addition, we are developing a lot of the technology in which we may not have to actually program these things, but we can have these algorithms in which we instruct through language, in which they talk back to us through language, and everything gets converted from actually natural language to motor controls in some kind of like machinery that we build. So this learning by instruction and this interaction through imitation and through feedback is also something that we do a lot of research on.
Okay. Moshe, can I respond to the line of technology creates new job, which is, of course, technology always creates new job. But this doesn't count unless the people who lost their job get new jobs. Otherwise, it doesn't help us. And what we have seen by the decline of labor participation, labor force participation for men is that people are not widgets. They don't easily move. There is an issue of can they upskill? Can they change their skills easily? What is the level of pay in the new industry? Some people say, if you have my pay, it's not worth my taking this job. Is it the issue of pink-collar jobs that are traditionally female jobs, and both on the supply side, men are reluctant to take these jobs, and employers are reluctant to hire them. There's the issue if I lost my job in Duluth and the new job is in Manhattan, I not be able to make the move. There are lots of barriers. So just saying there are new jobs, it does not solve our problem.
There's a second question I want to ask you, because you kind of left me hanging. You talked about this dramatic decline in labor force participation, but you really didn't say why. And wasn't it actually not because of capital or technology, but because of the flight of these manufacturing jobs to low-cost human labor?
So it's
Isn't that where most of the jobs went?
It's actually very, very complicated, and it's very hard to disentangle all the different factors. So it's very clear that partly because of globalization, many very low-cost industry fled the United States. But on the other hand, total manufacturing volume has continued to rise. So we have new industries, but these industries are very often very technology, very capital intensive, and are not hiring the same number of people. Or this, again, if you go and tell the people now from Appalachia, you have a job for you in California, they don't always want to move. I mean, it's complicated. People are not widgets. And so somehow our labor markets are not as efficient as they ideally should be according to neoclassical economics. And we have to acknowledge this inflexibility and inefficiency.
Okay. Well, we're out of one last question. At lunch, Kai-Fu sort of laid out a map for self-driving cars, which was farther in the future than most people in America seem to be comfortable with these days. I mean, I think he talked about 15 to 20 years in America and 10 years in China. Are you guys comfortable with the self-driving cars as, not as research projects, but as an industry being 15 years away in America? That's a long time. That's not 2022.
I'll let Daniela answer, but it is me say that talk and that the curves he showed along, for example, the payments, all of these that we knew, it's really amazing how much the embracing AI as something that may provide benefits to society is inspiring to me. Was very inspiring to me to hear these, not saying all the horrible things that AI can do, taking jobs, but embracing it as let's make these be something of benefit to society, of benefit to humanity. So I thought that was very inspiring.
And I completely agree. And I actually believe that we will see advances in autonomous products in China faster than in the US, because right now we are limited by regulation and by the scope of technology. I think right now we can have level 4 autonomy as products. In other words, we can take autonomous driving technologies and put them in closed environments where we do not need regulation and where things don't move very fast and where we don't have complex interactions. And it will take some number of years to go from where we are now to level 5 autonomy. I would say that driving in weather is a big challenge. Nobody can do that. I would say that driving in high levels of congestion is a really big challenge. So again, it's speed of the vehicle versus complexity of the environment versus complexity of the interactions. I think if you imagine a graph with these 3 axes, we are close to the origin, and we can head in different directions, and it will take an interesting 7 to 10 years, though I really do expect it coming. So if it comes in 10 years, we have a lot of time to rethink the trucking industry.
So we're out of time.
Can I have the last word?
You can have the last word,
no.
actually. I'm just one sentence. I'm used to hear the sentence, we have too much regulation, where the hottest topic on the table right now is, do we need more regulation?
Yeah, okay. So thank you all. You know, one thing that Kai-Fu didn't mention is that one thing that the Chinese are running out of now is people. In China, they'll be lucky if the robots come just in time. They're actually aging more quickly than many other Asian nations.
It's the same everywhere
Yeah.
around the world.
Not in Africa and Middle East yet, but everywhere else. Yeah.
Humans and robots can collaborate. What they cannot do, they can do each other eventually.
We are out of time. Thank you very much.
Thank you.
Thank you.